Welcome. Welcome to the LogiMAT forum in Stuttgart. Today we will demonstrating how AI-driven machine vision is transforming logistic. On stage with me are Suppa from Roboception, Shane MacNamara from sich, and Adrian Wick. Wick is correct.
Wick is correct.
From Stemmer Imaging. Welcome. My name is Oliver Scheel, and I'm here representing EMVA as a business development manager. Let me begin by sharing a few words about the European Machine Vision Forum, where EMVA serves as a platform for exchange information and practical value for its members, representing the interest of over 170 members from more than 25 countries. The EMVA members include all market players in the machine vision industry across different stages of value chain. These include manufacturers of hardware components in the field of sensor technologies, accessories such as optics and lighting, manufacturers of camera systems, system integrators, software developers, institutes, universities, consultancy, and the customer of our members, such as automation companies as well. Creating standards is very important for success in any industry, especially in the complex and worldwide machine vision sector. International machine vision standards help to make vision technology less expensive and user-friendly. And we are proud to host 3 internationally machine vision standards. As a summary, the EMVA is the leading organization for vision technology in Europe with a wide range of activities. One example, we are proudly hosting a member booth here at the LogiMAT. Together with 8 our members, we invite you to visit us in Hall 2, booth 2C18. Machine vision plays a device's role in the optimization of logistic processes. So what is exactly machine vision? We come from different backgrounds, and let's start by establishing a common understanding. A simple way to think about machine vision systems is as the eye of a machine. Machine vision is key to digitalizing the logistics sector, enabling solutions for tasks like identification, tracking, measurement, robotics, and much more. What can machine vision do in the logistic? Analysis is important, observing different types of parts, identification for tracking and tracing, quality inspection, checking if something is okay or not, button guidance helping with tasks like picking and placing items, equipment monitoring, detecting issues like vibrations or heat, and of course safety to be aware of people to stop accidents. What are the opportunities for machine vision in logistics? The digitalization of the logistic market is a major trend with significant implications for supply chain management, material handling, and warehouse operation. Machine vision is at the heart of this digital transformation, driving solution for identification, tracking, dimensional measurement, robot guidance, and many other essential tasks. The logistic industry is undergoing a major transformation, with AI-driven machine vision technologies leading the way. Learn how machine vision is reforming, improving productivity, and streamline processes. Let's begin with our first speaker. Dr. Michael Suppa, CEO and co-founder of Roboception. In his presentation on AI-based perception of unknown flexible items, Dr. Michael Suppa will explain why robot vision is important, the role AI plays in these technologies, and how these solutions are already being applied in logistics today. Michael?
Thank you.
The stage is yours. Thanks.
Yeah, thank you very much for the introductory words. Okay, yeah. Welcome to my presentation on AI-based perception of flexible items. As introduced, my name is Michael. I'm the CEO of Roboception, Munich-based company. I will start with a small motivation. So this is actually a quote from 2015. And Rodney Brooks, a famous roboticist, said, if we were only able to provide the visual capabilities of a 2-year-old child, robots would quickly get a lot better. And this is actually how we start. On top of that, I will give you a quick example here with this video, how it actually looks on the shop floor. So we have a lot of machines, we have open spaces, we have a lot of lights, we have reflections, we have everything in the shop floor, and we as the perception guys, we have to make sure that we detect the objects, locate the objects, and then place them accurately, not only for known, but especially also for unknown objects. What are the challenges? For robots, we need to have items that are coming in an under-organized way to put them in some kind of order for the robot to put them into the application, be it palletizing, be it actually just stacking, packing, or any of these. And there's a lot of processes in logistics especially who are quite labor-intensive. And some of the tasks are actually very difficult because we are dealing with delicate items. So as opposed to industrial automation, where we mostly have metal parts, some are flexible. Items are hard to exactly place or locate correctly. And they all look different, which is the main challenge here. In terms of the perception, just give you a little bit more here. So we have to cover with different lighting conditions and also with perspective. So hardly ever see the part in full scope in the camera, but there's a lot of side views. We have to deal with that. The material varies a lot from shiny, transparent, translucent, black, and we have very different sizes and distances. And then it comes to a robotic application where the parameterization of the task requires some expertise. We have the test implementation time, and then we want to have something like 97% availability, which means successful picks. So even one mispick can bring my whole statistic to very far down. So we have to make sure that the machines are running under all these different conditions. And we have to have, when we're talking about AI, we have to have data that covers all that variations. And this is really hard to achieve. And also then to train it in a way that we know exactly what we get in the end. So what are we providing? On the one hand, we are dealing with the hardware of the systems. So we are dealing a lot with stereo vision on our end. So we have a couple of systems here from resolution, from close range to far range. We have a compute. And on the other hand, we have our software modules that basically are the core in order to identify the correct placement and location of the part. Let me start with a small example here. So this is actually an example from the known world, so to say. Here we know the parts exactly. And what we did there, and this is the inspiration how we deal with the unknown items, is that we have CAD models of the part. We generate synthetic data sets based on the CAD model. We provide these models so that we train each part individually, and we achieve a very high accuracy. And what you can see to your upper right is basically all the illumination constraint that we can simulate with that. So we can have dark rooms, we can have large areas, and that is all in the synthetic data when we train it. And we took this inspiration, and I will show you a little bit of video here, which actually shows how many different variations we can actually cover with these kind of data. So taking this known parts, we basically did a very similar approach for the unknown parts, because the challenge here is we don't have enough data, but we have some very general data sets that we can use. And then we started to say, hey, if we want to have a model that is basically able to locate bags, then we start generating synthetic data from bags, because there we can squeeze in, we can bring them in different scenarios. So everything else that we have to do hand-guided, so we have to put them somewhere, we have to label them, we have to know exactly where the parts are. We can do in simulation, so we can also train our unknown parts by simulating for special bags here. We can give them different textures. Of course, we need a little bit more data than we would use for known objects, but this is basically the refinement, and with that we can find a very, very nice way how we can actually locate unknown parts. So we're taking the same approach from the known to the unknown by enriching general data sets with synthetic data, which really expands the capabilities of the system in the training and also helps us to have control on the data, because we are not depending on someone who's pre-labeling the data for us, who may not know what we exactly want to do with it. So we have full control on the data, which is a big benefit for a software product, especially for online items. Instead of training a part, we're training a category. So in the first case, it was this one metal part. In the second case, it's a object categorization, such as bags, for example. Yeah, what else comes on top when we want to go with the robotic expectation? The AI part is one, but then also we need to somehow put it to the robot. And here we're seeing a lot of expertise needed, because especially if you're coming from logistics, you're not the robotics expert, so how to program your application. There's actually two ways to do this. A very generic interface where you have your expert programs, but on the other hand, you also have a very various way on how to do this in kind of ecosystems where they're providing you a high-level application. And last but not least, most people dealing with cameras are not vision experts, and what we are providing here is basically also very intuitive web GUI. You can see this in this quick video. So you can do everything by click and drag, and people are mostly used to this kind of interfaces, so there's no parameter tuning by hand. The data tuning we did before, the parameter tuning is not needed anymore. With that, basically the key insights on this area. So the one is you have to deal with the good data instead of the big data. So what is the task relevant data that you really want to work with? So you have the cut model, you have the model of the object categories. Second is that you want to do it plug and produce. So basically easy integration, smart sensors that you can really scale up this software platform. And the last one is that you don't use any expert knowledge on the customer side in order to interfere with the system. So that is really the third thing, to make a vision solution in robotics successful. Last, I will give you a couple of examples. One of them is more from the industrial domain. So here you see basically the large variety of parts from black, shiny background, and so on. So this is where we actually use the synthetic data to learn how good it can work under these conditions without really needing a lot of real data. The second example you can see here, that's from the warehouse. Here we have the task to pick these different boxes and actually place them. Here, basically, the parts are more or less known, but still you have a lot of labels on the part, you have the wrap, you have a lot of different information that may look two boxes like one. So you have to make sure that your segmentation works very well so that you can separate all the parts from each other, because most of the time you don't know the exact size of the baggage that's coming in. Another example here, also here, it's important that the texture is used in the correct way, because you want to place these little chocolate bars all in the correct orientation. So in many cases you don't care about the texture, you want to do a texture independent. In other cases the texture is very important for the task. So here the training is a bit different, because in this case we want to use the texture to get the right orientation of the part and place them all accurately on top of each other. Last but not least, the application with the segmentation and AI. And I also will just give you a small video here in the next slide. So what you can see here is these bags. We're getting grasp points on them. We want to get the right orientation. And you can have these shiny bags. You can have very blue one. It's all trained the same way. So there's no difference in training between the transparent bags, these pinkish bags, and all the others. So what we did is a very general way of detecting these kind of bag strategies. With that, I'm coming to my last slide. Just a quick summary of today's presentation. So what is important is that you can start quickly. Setup is doing fast. using standardized interfaces, having control of the data, and also the way how you integrate it in the machine, either via standards, platforms, or a programming interface, and user friendliness. So none of the people that are using our products need to be in-depth vision experts, and that's also very important for the application. With that, I thank you very much for your attention. I hope I was able to give you some insights on picking flexible items with a new synthetic data approach. Please visit us, Oliver said it already, in Hall 2, booth 2C18. And yeah, I hope you're enjoying the fair. And with that, I hand it over to Shane, or are you doing the moderation?
Thank you very much, Miguel, for your exciting presentation. Our next speaker is Shane MacNamara. Shane is Senior Vice President Research and Development at SICK. He gives a presentation on AI game changer in image-based solution for the logistics industry. Learn more about the real and potential benefits of AI and how our member SICK integrates AI into his products. Please, your stage.
Thanks, Oliver, for the kind introduction. I'd like to start off with a couple of words on SICK. We're a global manufacturer of sensors, sensor solutions for industrial applications. Our main focuses are in factory automation and logistics automation. The theme of the talks today are the application of artificial intelligence to vision-based logistics solutions. This is really exciting for us. We've been doing it for quite a while, and it's a great pleasure to share our thoughts with you on this today. Now, we have the claim of SICK sensor intelligence. We've had it for over 20 years. And it's really about capturing what the sensor can give us from the environment, processing this, and providing good information for decision making for our customers. Now, being able to extend this a little further while leveraging AI opens up a lot of new different applications for us, which are also extremely important for the logistics domain. Just to give you some context as to what we're talking about today, or what applications we're talking about, let's take the warehouse or the intralogistics context here. Typically, you have inbound, you have conveying, you have sorting, you have storage, you have picking, you have outbound. And I just want to focus on a couple of areas here and the applications that we're attacking in these domains. And let's start first of all with inbound, the topic of depalletizing in the intralogistics context, and how to incorporate an automated inbound processing within the standard material flow process. Now here we have the example of a 3D vision sensor mounted on the robot. It's capturing the dimensions and the positions of objects or items on the pallet, and it's basically generating a pick position for the robot or a gripper position for the robot and passing this onto the robot. It's using pre-trained networks, so it pretty much works out of the box. It can be implemented in a plug-and-play fashion. If there are items which aren't recognizable, they can be then trained afterwards. So it's a big step to make this kind of plug-and-play, highly integratable, and also then in terms of automating the inbound process. Let's zoom out again to the domain of conveying and sorting. And we look at an application here where we're talking about high volume throughput of the order of like 30,000 parcels per hour going through these systems. I'd like to talk about a particular sensor that we have. It's the ICR 890. It's a reading tunnel. It's an omnidirectional reading tunnel, capable of processing both cubic and irregular objects. It's basically reading the 1D, the 2D codes. It's producing very high resolution monochrome data or images and also color images. So we can do an awful lot with this sensor based on the data we have, all the way through to going beyond the identification with codes, but moving on to digital fingerprinting. So there are 5 applications here I want to look at in the next few minutes. The first, single item verification. And we said that processing, the inbound processing is automated. Then we have the case of singulation, being able to individually put the items onto the conveyor. The singulation process is normally working very well, but there are a couple of % of parcels which aren't singulated. In this case, the side-by-side detection of items within the reader is important. First of all, to avoid freight problems in terms of charging, and also in terms of the actual shipping process, that the parcels go to the right destination. So any multiple item here in the reading process is then localized and sent back to the singulation process. Now, per se, this is an extremely complicated process because we're dealing with a lot of different varieties of objects. Being able to estimate or to classify side-by-side objects or objects covering another object is quite a difficult process. If you look at all the items that go through a sortation process. Also reflections from the tray, non-cooperative materials, various different colors. So it is a process or a classification process which is extremely well suited to the application of AI. Now, next topic is dangerous goods. Now, there are stronger regulations in place for the transportation of dangerous or hazardous materials. These include flammable liquids, gases, poisons, explosives, lithium batteries, etc. And here, the automated detection of hazardous materials during transport has a number of benefits. First of all, manually processing this is a very time-consuming and expensive task. We'd rather have a fully automated process in this case. We're also able to recognize false handling of such materials and prevent accidents along the process of transportation. And in general, we're optimizing the material handling. Now, these AI classifiers work very well with these hazmat labels, really independent of position on the boxes, etc. Next topic, OCR, or optical character recognition. And this is an integral part of identification solutions in general. And classically, the OCR process has been running separately on a different processor and a different hardware. And now with the advances of OCR and deep OCR, we can actually run these processes directly on the camera. What are the advantages then for our customers in this sense? We're reducing the amount of hardware in these systems, in these tunnel systems. We're also giving the customer the immediate results from sorting. We're able to process the OCR within about 50 milliseconds, which means it can be actively used in the sorting process. And all in all, we have a reduction in complexity for the customer. Next topic, personal data anonymization. This is the removal of personal data from images which are captured by the camera and then sent to a higher order IT system. What's behind this? It's the General Data Protection Regulation. This regulation is benefiting all of us, protecting the handling of our personal data and also the free movement thereof. If we just send captured data directly onto other systems, we in general have a compliance problem. What this AI function does in this case is it localizes any personal data, it makes it unreadable, but at the same time it allows other data, whether it be 1D, 2D codes or non-personal data, that will be transmitted onto other systems for further use. That's important for us in general because the storage of this data is necessary for improving the processes that we have, the read rate, etc. It's also important for documentation process in general. And with this solution, we have a full compliance in the deployment of the system. Last topic is object classification, which is in general a very challenging problem because of the diversity of products and items that we're dealing with on a day-to-day basis. What we're in general seeing is an increase in the proportion of bags or polybags, for instance, in the mail mix that we have. Polybags are very, very, very popular due to their cost, due to their being lightweight and also their durability. But it actually makes for a certain amount of challenges in terms of being able to handle the material in the process. This is where we have a bag box classification where we can actually sort or classify robustly the different types of materials, and they can be sorted appropriately. For the customer, it means that sorter crashes can be avoided, and the idea of legal for trade dimensioning, which is typically done for boxes, is not necessary in this case. There are further examples of where classification becomes important. For instance, in the conveyability of items such as cylinders, etc., which can roll off trays and belts. There's also the case of quality inspection, being able to see if a package has been damaged or there are some anomalies on the package during the processing, which is important for traceability. It's also very useful for portfolio analytics, so knowing exactly what's going over the conveyors. So, just in summary, I can say that AI-powered solutions, vision-based solutions in logistics is very important. We're automating more processes than ever before. We're improving the accuracy of our systems. We're enhancing the safety of our processes, and in general, we're optimizing warehouse operations. So, thank you very much.
Shane, thanks a lot for your overview about the real and potential benefits of AI. Our last speaker is Adrian Wick. In his presentation, Adrian, application manager, Stemmer Imaging, will demonstrate how advanced vision guide robotics are transforming logistic efficiency. Discover how intellect picking solutions are shaping the future of automated operation.
Thank you for the introduction. Good afternoon. I'm sure that you already know that the automation of your logistic processes can lead to cost reduction of up to 30%. But maybe while trying to automate your processes, you have found some gaps. Some processes that cannot be automated only using robotics. You need something more. Today, I will explain you how Stemmer Imaging can help you to close these gaps and to achieve the complete automation of your logistic processes. First of all, let's see the context. You'll know we are working on a demanding sector full of challenges. Challenges as seasonal demand increases, market rules, and we must attend our customer requests when they need us to. We need processes, we need systems that are able to handle with peaks of production. We also deal with unstructured workflows. We work with different products, with different references. And it's difficult to have dedicated lines for each product. So we need systems, we need processes that are able to handle different products. And not only that, the changeover between products must be automatic. And of course, labor shortages. We all know how difficult it is to find the staff for our factories. And we all know the benefits of the automation in this regard. So we all know these challenges. These challenges are real. We built in Picker the solution for these exact needs. And what is in Picker? In Picker is a powerful vision-guided robotic system developed by Stemmer Imaging. We are bringing together the potential of machine vision and the power of robotic to create a plug-and-produce vision-guided robotic system for pick-and-place automation across industries. InPicker is designed to simplify, standardize, and optimize your logistic processes. And what InPicker can do? Well, as I mentioned, InPicker is a vision-guided robotics for pick-and-place automation. So InPicker can solve from the easiest unit picking, the picking of a single box, a single isolated product, to the most challenging random bin picking. Picking of randomly piled products inside a container with any order. And you can solve all this range of applications with the same InPicker solution. More focus in the logistics sector, the Picker can solve your depalletizing application, the palletizing of individual boxes, bags, or sacks, or the well-demanded depalletization of complete layer of boxes, a good way to optimize the cycle time of your depalletization application. And all this supported by logistic features. Features as pallet and interlayer detection and location, the capability to differentiate between European, American, and Chinese pallet, overhand detection, and so on and so on. And what is even better, we are releasing this year a complete InPicker Logistic Edition. A new edition of the InPicker with more logistic features, with capability to solve more logistic application, and with the capability to solve them with more efficiency. Now we know what is InPicker. We know what InPicker can do. Let's see what InPicker consists of. InPicker is integrated by these three components. The InPicker box, the control unit, providing reliable real-time data for a smooth operation. It's integrated also by the InPicker Vision, the 3D sensor, the ready-to-use imaging system. And it's composed also by the InPicker Ear, the software, the centerpiece of your pick-and-place automation application, the brain behind the operation. Let's see more characteristics. Let's see more in depth the InPicker Ear. The InPicker Ear is the software developed by Stemmer Imaging during more than 10 years. 10 years in which the software has grown directly in the production lines, nurturing and growing with the needs of our customers. So if you have a problem, we've probably been there and solved it. The InPicker Ear also have an intuitive, user-friendly graphical interface, because you don't need to be an expert in robotic. You don't need to be an expert in machine vision to do the configuration of your bin picking application. You don't have to write a single line of code to do any configuration with the InPicker. Also, the InPicker Ear supports 2D and 3D imaging methods for complex object recognition. 2D and 3D imaging methods based on classic detection algorithms such as 3D surface detector, pattern recognition, detection of primitive forms, and also state-of-the-art detections based on deep learning. Here, you can see two examples of detections made with our trained deep learning models. You can see the detection of single boxes, and you can see the recognition of interlayers. Interlayers is the separator on this cardboard sheet between layers of boxes. Let's continue with more characteristics of the InPicker. The in-picker box is, has industrial-grade reliability. It has been proven in hundreds of challenging environments of the automotive and the logistics sector. It is manufactured by Steiger Imaging here in Germany. The in-picker is flexible and scalable. Its modularity allows you to solve from the easiest small application to the most challenging high-volume processes. Also, the in-picker is hardware independent. It's not attached to a brand of camera. It's not attached to a brand of robot. It's compatible with the main robot brands in the market. It's compatible with ABB, Fanuc, Universal Robot, and so on, and so on. And you can see in the in-picker box, you can see all the information of your current vision cycle. But not only that, all this information, it's also saved in a database, so your production is perfectly monitored and tracked. And finally, the in-picker vision, the eyes of the machine. The ready-to-use imaging system. As I mentioned, in-picker is hardware independent. So you can use many cameras in the portfolio of Steiger Imaging. You can use cameras with different field of views, cameras with different 3D technologies. Because it's not the same to do a picking of boxes in a pallet of 2 meters than doing beam picking of plastic parts inside a little box. And you can solve both applications with the same in-picker system, because it's flexible, scalable, and hardware independent. Now we know the characteristics of the in-picker. Let's see the steps of a picking cycle. The first step is taking a capture with our ready-to-use imaging system, the in-picker vision. With this capture, we do a mapping of the environment. We detect, for example, the container, or we detect different obstacles. And once the mapping of the environment is done, with our 2D and 3D imaging methods for complex object recognition, we detect the parts that must be picked by the robot. Once the parts are detected, the in-picker calculates the grasping position and discards the grasping position that can lead to potential collisions of the robot. So once we have the safe grasping position, the in-picker sends the coordinates to the robot, and the robot starts with the extraction of the parts. After the extraction of the parts, the robot should place the part somewhere. The in-picker can also help with this placement. The in-picker can locate the position of the nest where the part should be placed. And not only that, after placing the part, the in-picker can check if the part has been placed properly. These are the mechanical, let's say, steps. But there is a last important step. All the information collected during this process, the 2D capture, the 3D capture, the coordinates of the robots, and so on, all this information is saved in a database. You can access to this database through the in-picker analytics, an application integrated in the in-picker year that allows you to have all the information of your production. So your production is perfectly, with in-picker, is perfectly monitored and tracked. You know that the automation of your pick and place applications means benefits for your production. In-picker means efficiency gains with continuous 24/7 operation capability. In-picker means quality improvements with more precise pickings and with more repeatable processes. In-picker also means operational benefits, lowering your labor dependency. And in-picker is safety, because with in-picker, you have a system that's able to avoid collisions of your robot. You have a system that reduces handling and manual handlings inside your factory. So, in picker means direct benefits for your business. And all this supported by the excellent structure of Stemmer Imaging and its technical competence center, with 7 engineering teams with more than 60 engineers all across Europe, North America, and Latin America. That's why InPicker is a global product with local support. Now, you know the benefits of the automation of your pick-and-place applications. You know the benefits of InPicker, so do not wait to increase the efficiency of your logistic processes. Thank you.
Thank you very much. Thank you very much, Michael, Shane, Adrian, for your exciting presentation. And thanks for demonstrating how AI-driven machine vision is transforming logistics. Thanks a lot for your attention, and we invite you to visit us in Hall 2, booth 2C18. Thank you very much.